Hello class, this is the continuation of our topic for the electrochemistry, which mainly involves the problem solving to the sample problem, which is only 1, 2, 3, 4, and 5 problems that we will solve in this, which involves a Nernst equation. Okay, now let's start to this first sample problem. Okay, consider the galvanic reaction of this galvanic cell. Now dito sa ating reaction nito, you will not discuss the element itself, but rather this is a redox reaction kasi. So you will balance this using the electrons na which one makikita ninyo mamaya. Okay? And now, give the balance cell reaction, calculate the E naught for the cell. So these are the overall reaction. Doon nga sinabi ko kanina, hindi mo siya ibabalance using the elements itself, but rather you will use the two half reaction which comprises of the oxidation reaction and reduction reaction. Ayan. So ito yung mga half reactions natin. So how do we balance this? Okay. Dito sa ating half reactions na ito is pagsasamahin mo siya to come up with this overall reaction here. Ayan. Ngayon, meron tayong table dito sa ating appendix 5 ng ating analytic chemistry na dito ninyo makikita yung mga half reactions and their corresponding standard reduction potential. Yun nga, yung kanilang E naught. Ayan. Ngayon dito, ang gagawin natin is here, unahin natin i-balance yung manganate ion na na-convert daw sa may manganese. Okay, syempre, dito sa may table, para mas madali ang natin, ang ating pagsasolve, is titignan nyo na lang siya dito sa may table. Ayan, no? Hanapin niyo manganate converted to manganese. Ito na agad siya. So, syempre, isusulat nyo na yan, di ba? Ayan, susulat nyo na, blah, blah, blah. Pero, I will teach you how to balance those reactions without looking at the table, okay? Okay, ngayon, i-balance natin. So, as you can see here, the product lacks oxygen. Tama? Now, when it lacks oxygen, you will add H2O to the product or reactant, basta kung saan lacks oxygen, add H2O. So, mag-add ka ng H2O here. Pero ilang oxygen ba ang kulang? 4. So, you will add 4 molecules of H2O here. Now, as you would notice, guys, dito naman ngayon, the reactant lacks hydrogen ion due to the presence of H2O from the H2O here. And when it lacks hydrogen, guys, okay, you will add an H ion here to the reactant or kung saan may kulang ng hydrogen. And guys, we are talking about the balancing a half cell reaction for the redox reaction, not for the typical chemical reactions that occurs in the chemistry. Ngayon, ayan, here, so there are 8, tama? So you'll balance it using 8. Ayan, so balance the reaction natin in terms of the element. But since this is a redox reaction, kailangan niyo i-balance yung charges to maintain the charge balance of the reaction. So kung mapapansin niyo, we have, dito sa reactant, we have -1 and 8 positive charges. 8 positive charges na kung saan we killed a 7 positive charge. Dito naman ay 2 positive charge kasi nga 'di ba 2 and 0. So therefore, ilan ang ima-minus mong electrons, 'di ba? When redox reaction, you will use an electron to achieve the charge balance of the reaction here. Ayan. So ilan ang saan ka mag-minus sa reactant sa product? Siyempre sa reactant, ilan yung ima-minus mo? 5 electrons para maging 2 positive din siya para ayan no, para ma-balance sila. So you will add a 5 electrons here na kung saan magko-conform dito sa may table natin, di ba? Hindi mo na siya kailangan tignan. Pero kung gusto mo mas madali, syempre, titignan mo. Ayan. So, isulat ulit natin. Medyo magulo siya. Kamaya natin isulat. Now, dito naman, isulat naman natin dito sa may chlorate, which is the, natin, ayan, the chlorate, perchlorate, I should say pala, converted into ClO3 negative here. Ayan. So, syempre, titignan niyo siya sa may table. Ayan. Chlorine siya, tama. Ayan. And as you would notice, guys, wala tayong perchloric ion dito. Diba? So, hindi niyo siya magagamit. So, ano gagawin ninyo? E di syempre, magko-on kayo dito. Gagamitin niyo yung method na ginamit natin dito kanina. So, saan may lack oxygen dito sa may kabila? So, ayan. H2O, only 1 molecule of H2O kasi nga 4. 3, 3 plus 1, 4. So ilang hydrogen? Hydrogen, dalawa. So 2 each ion here. Now, na natin, na-balance na natin in terms of elements. Now, we will balance this in a charge balance. Okay? Dito, negative plus negative, so neutral plus positive. Dito ay negative 1. Di ba pag redox reaction, ang panggamit mong balance is not proton, but rather the electrons. But rather the electrons. Okay? So dito, ayan, in order to minus 1, in order to negative 1, para mag-balance sila. So, plus 1 electron here. Now, as you would notice, guys, from the two reactions here, para silang reduction. And these are two half reactions na kung saan, ayan, half reaction siya. So, saan dito yung reduction? Saan dito yung oxidation? Kasi nga, this is a redox reaction here. Now, di ba, as discussed sa may last lecture natin, dito sa ating natin is, dito, here, nasa na, ito, di ba? We will look at the standard reduction potential na kung saan, kung ano yung mas mataas ang standard reduction potential, siya yung may capability na mang-oxidize. Ibig sabihin, siya yung marireduce. So, saan ba dito yung maakuan natin? Saan dito sa dalawang to? So, this one has a higher. So, ibig sabihin, siya yung marireduce and i-oxidize niya to. Kasi lower di ba? So, ang mangyayari dito, itong reaction na ito is marireverse. Ayan. So, marireverse siya to form ayan. So, reverse mo siya. CO3 negative plus H2O to form a product of ClO4 negative plus 2H plus 1 electron. And then, rewrite mo yung kabila. Here, manganate plus 8H positive plus 5 electrons. And then, manganese 2 positive plus 4H2O. Now, kung mapapansin ninyo, ang ika-answer kasi natin usually sa redox reaction is yung electrons. But this one here, the reduction, 5 electrons, dito naman ay 1 electron. So, ilan yung i-multiply mo dito sa may reaction nito to achieve a 1 electron, 5 electron para mag-equal sila. Siyempre, 5. Ito, times 1. Times 1. Usually, sa algebra, hindi naman nilalagay yan. So, we have to, ayan, so times 5 mo silang lahat, ClO3 plus H2O here plus 5 H2O all over, okay, ClO4 negative, that's 5 plus 10H plus, but 5 plus 5 electrons, ayan. Tapos dito naman, rewrite mo lang ulit. Manganese ion plus 8H positive plus 5 electrons equals manganese 2 positive plus 4 H2O. Ayan. So ayan, ang mangyayari dito ngayon, using the principle of Hess law, if you're familiar, so subtract mo ngayon sila dito, di ba? Ayan. So magkaaroon ng subtraction pero not na. So magma-minus yung nasa opposite side of the reaction, whereas the reactant will subtract the product from the other reaction here. So mangyayari dito is ma-cancel kasi para sila. And then dito, saan pa ba? Dito, H2O, mawawala dito. Dito ay magiging 1 kasi minus 1. And then dito, sa H naman, mawawala ito. Dito ay magiging 2 na lang. Okay? So the overall reaction for this, ang balance half cell reaction niya will be manganate plus 5 ClO3 or chloride, hypochlorite, plus H2O equals 5 perchlorate plus Mn manganese plus 2H positive. Ayan. So sir, sa Hess law po kasi ang nangyayari kapag nag-reverse kayo, nag-multiply ng reaction, is nare-reverse po siya tapos nababuwa na ita-times mo rin, i-multiply mo based on sa may coefficient na multiply mo. Will it affect the standard reduction potential? Maapektuhan ba siya? No. Hindi siya maapektuhan, but rather, mare-retain niya yung same values. Kasi nga, di ba dito, sa ating chloride dito, nag-reverse tayo. So, supposedly, sa Hess law, magiging negative siya. Tapos ito times 5 mo. But that's not the principle of that. The standard reduction potential will retain its value no matter kahit anong gawin mo sa may reaction niya. So ayan, mariretain 1.51 and 1.19. Ayan. So 1.51 volts and 1.19. Sorry. 1.19 volts. Ayan. So ganyan. Ganyan. So this one here is the reduction. And dapat nasa taas yan. And this one here is oxidation. Pero ang interest lang naman natin dito is the overall reaction. So this is the balanced half cell reaction. Dito natin. So take a screenshot guys so we can proceed. Yan. And then here naman, dito, mapapasin, dito here, calculate the E naught. Dito ngayon papasok yung Nernst equation. Whereas it has a formula of E cell is equals to E naught cell minus 0.05915, that's 5915 all over N, times log of K. Now the E cell is the difference of the, kuha natin, ito, pag i-expand mo yung formula na, E naught cell is equals to the E right minus E left, or E positive minus E negative. So, saan ba nag-origin yan? Di ba sa ating galvanic cell, guys, we have this galvanic cell here, ayan, with a corresponding voltmeter. Di ba yung nasa left, siya yung nasa anode. Ano ba yung nangyari sa anode? Oxidation. And then sa may left naman, sa may right, is ito yung cathode. Ano nangyari dito? So, reduction. Dito sa may reaction natin, dito, sa may ko natin, dito sa may taas, ano ba yung na-reduce? Ano ba yung na-oxidize, di ba? Ito yung reduction, ito naman yung oxidation. So, ang gagawin mo dito, just E naught cell is equals to, ayan o, balik tayo sa may formula na to, dito, ayan, dito. So, ang mangyari dyan, E naught cell is equals to E right. Ano ba E right? 1.51 volts, tama. 1.51 volts minus oxidized E left is 1.19 volts is equals to 0.32 volts. So that's how you get the answer using the Nernst equation. So sir, how do we calculate po this E cell? Okay. Kapag may given kang concentration and then yung N natin is 5. Sir, bakit 5? Kasi nga 5 electrons yung nandito sa atin. Okay? So that will be the one natin. So take a screenshot, guys. So we can proceed on our next problem here. And ayan. So let's proceed on our next problem. Ayan. And gusto ko lang isingit pala, guys, na itong table na ito is i-upload ko naman. So you don't have to worry here. These are just the standard reduction potential. Ayan. So the manganese, ayun yung di ba kanina, 1.51 volts. Pero yung chloride dito is wala na 1.19. Kasi dapat yun ay nasa ClO. Oxygen. Nasa oxygen here. Oxygen. Wala dito. Ayan. So, it is a standard value. Maghanap ako ng mas kompleto. Ayan. So, we have now in sample problem number 2. Okay. Describe completely the galvanic cell using line notations based on the following half reactions under standard condition. Okay. Ano ba yung line notation? Di ba ito yung tinutukoy natin? The line notation are the notation of the half cell in terms of representing a line. Whereas the here is the electrode, the junction, the concentration, the salt bridge, and then the concentration, the species present times the concentration with its corresponding concentration and the electrode use. So dito, gagawin natin here. Hanapin ninyo dito, di ba? Dodrawin ko ng half cell dyan. Ayan. So it is salt bridge. Ito yung voltmeter natin. Ayan. So ang hanapin mo dito, ano yung nasa left and ano yung nasa right. Okay. Kung ano yung mas mataas na value, di ba? Sinabi ko kanina, siya yung mare-reduce. Tapos i-oxidize nito. So, ano yung mas mataas yung nasa value? Siya yung laging nasa right. Then, kung ano yung nasa left, yun yung nandito. Tama. So, therefore, this one here, ito yung nasa right. And then, ito yung nasa left. Now, let's write the one. Pero dito, mapapansin para silang reduction. So, you will reverse the reaction here to conform, ayan, Fe2 positive. Ayan, kasi siya yung na-oxidize. Kasi na-reduce form lang sila. Ayan. So, ayun yung mangyayari. Now, what are the electrodes? Okay, pwede kang gumamit ng platinum because this is an inert. Or pwede rin yung corresponding metal nung ating ions na nandito. So, ang mangyayari dito is, ayan o, Fe, the electrode, or pwede rin PT, kasi inert yan. Ang matataka dyan sa potentiometer. Pero, recommend Fe na lang para hindi na tayo malito. Sa classic one. Ayan. So, Fe2 positive, comma, kasi naging Fe3 positive siya. With this X molarity. And then we have the salt bridge kasi nandito siya. Yan, the Fe. Then the salt bridge, kung saan yung Ag. So, Ag positive, we have a unknown concentration. And then yung electrode na Ag. So, ayun. Electrode and Fe. Yan. And then if you would, kung gusto nyo kunin yung E not cell, pag minusin nyo lang siya. So, 0.080 minus 0.07, that is equals to 0.03 volts para sa E not ng cell. Ayan. So, take a screenshot so we can proceed to the next problem here. Ayan. Ayan. So, E not is 0.03 volts. Nakalimutan ko lagyan ng states. So, this is supposedly a aqueous state. Aqueous state is supposed to be solid. This one here is aqueous, and this one here is supposed to be solid. Ayan. Sorry, I failed to include that. Okay. Next sample problem here. Ayan. Calculate the Gibbs free energy for the reaction. Is this reaction spontaneous? Okay, so these are the half reactions for the one. Ayan. Wait. Okay, for the G naught. So, paano kaya yan? Mapapansin nyo naman, guys, is yung, obviously here, ang na-oxidize is yung iron. Tama? Ayan, oo. So, we will reverse this reaction here, Fe. Siya magiging Fe2 positive plus 2 electrons. Ayan. And then, so delta G, meron tayong formula kanina na delta G is equals to negative NF E naught cell or G naught. So ayan, ang gagawin nyo lang dito is N is the moles of electron. Ilan ba yung electrons na gamit, di ba? They're both 2. So negative 2 times what is the Faraday's constant, di ba? 96485 coulombs per mole, or coulombs is joules, joules per kwan. Ayan. Sige mamaya. Ayan. And then the E naught cell is ano ba E naught cell natin? Ayan, no? Pag minusin mo yan. So, i-write the E naught cell. Ano i-write? Nasa right, ito, reduction. So, 0.34 minus negative 0.44, which is on the E left, the anode. Don't forget the units. So, volts, that is magiging positive to. Ayan. 0.78 volts. So, ilalagay mo na siya dito. 0.78. Whereas volts is equals to joules per coulomb. So, lagyan mo dyan na joules per coulomb here. Ayan. And then, dito pala sa may 2 natin, alimutan ko, that is 2 moles electron. Ayan. So, maka-cancel. Maka-cancel. Matitira yung joules. So, ang sagot dito is, I'll just get my calculator. Wait lang. So, ang sagot is negative 150 516. 516.6 joule. Or negative, ano natin, 1.5 times 10 raised to 3 kilojoule. Ayan. So, the answer is, the reaction is spontaneous. The answer is yes. Kasi nga, negative yung value ng Gibbs free energy. Kapag kasi negative ang value niya ng ating Gibbs free energy, siya ay spontaneous. Kapag naman positive, non-spontaneous. So, ayan. So, take screenshot for the one. So, we can proceed with the other one. Ayan. Okay, next sample problem. Describe the cell based on the following half reactions. Okay, another line notation. And then, you will calculate the E cell of the reaction kung saan ito na. Meron na tayong kwan dito. Mga concentrations here. As you can see here, ayan, papansin nyo. Ayan. So, first step here is to ayan. So, first is to balance the pertinent reaction. So, I will just rewrite here BO2 positive plus 2H plus electron equals BO2 positive plus H2O or water. E naught is 1.0 volts equals to zinc 2 positive plus 2 electrons. Yan. And zinc solid. E naught is equals to negative 0.76 volts. So ito ay reduction. Ito ay oxidation. Sir, bakit po oxidation? Kasi nga, negative, mas lower yung kanya, yung standard reduction potential. So, dapat ang supposedly reaction niya is in reverse. Kasi di ba, kapag oxidation, the electrons is on the reactant. Yan. So, mababara na yan. So, we need to balance based on the electrons. Here, 2 electrons. This one contains 1 electron. So, you would multiply this by 2. Yan. And you will get a 2 VO positive plus 4H plus 2 electron equals VO 2 positive 2 plus 2 H2O, and then zinc equals zinc 2 positive plus 2 electrons. So the overall reaction will be, so product reactant cancel yung electrons, and then water. Meron ba tayong water dito? Makikita. Wala. So ayan na. You'll write the reaction here. So zinc solid plus 2VO2 vanadium dioxide to positive. Positive pala. Positive plus 4H or hydrogen ion equals to 2VO2 positive plus zinc ion plus 2 molecules of water. So these are here. Yan. So syempre, describe lang natin siya sa half cell reaction natin. Ayan. So oxidation and reduction. Ba't ba nag-balance ba muna ako? Ayan. Hindi, computein muna natin to. Ayan, computein muna natin yan. So syempre, when you andito, in order to calculate this, you will use the Nernst equation, which has the E cell is equals to E not cell is equals to minus 0.05915 all over N log times equilibrium constant. So dito na tayo magkakawan. Isa-isahin natin. So what is E cell? Ano ang E cell natin dito? Ayan, no? Pag minusin mo lang. 1 minus negative 0.76. That is 1.76. So E cell, ayan, no? 1.76 volts minus 0.05915 all over. So ilan yung electrons na na-generate natin dito? So 2 electrons. So all over 2. And then what is the equilibrium expression for this reaction, di ba? So product all over reactant. So ito ay K equals to VO 2 positive squared kasi coefficient ng 2 times the concentration of zinc 2 positive all over the zinc solid. Si zinc solid is excluded in the equilibrium. So VO 2 positive squared and then each ion to the fourth power. So i-impose mo lang siya dito sa ating reactions here. Ayan. So VO 2 positive squared times zinc 2 positive all over VO 2 positive times each ion 4 positive. So substitute the known values. So ano na ba yung mga values mo yan? Ito given naman sila. Tama? So ayan, you just have to substitute here. So 1.76 minus 0.05915 over 2. Then log. So ano yung VO2 positive? That is a 1.0 times 10 raised to negative 2 molar squared. And ano yung concentration ng zinc natin? Is 1.0. 1.0 times 10 raised to negative 1 or 0.1 na lang pwede naman. Times the vanadium dioxide ion here. Ayan, 2 molar. So that is 2 molar, 2 squared. Ano mo lagi squared dito? And then for the hydrogen, 0.5. 0.5 raised to the fourth power here. So magkaaroon na lang ako ng direct computation. I'll not do this step by step. Pwede rin naman gawin yan. So 1.0. 0 times 10 is 2 squared. So 1 times 2 squared times 0.5 is to the fourth power. And the answer is, ayan na, 1.89 volts for the E cell, which conform to the answer na 1.89 volts. Yan. So in terms of describing the cell notation, let's just describe dito na describe yung cell notation niya. Ayan, dito na lang. So my apologies if napaalim. Yun pa yung inuna ko. Ayan. So the reactant, saan ba? E left and E right. Ayan, E left and E right. So this one is on the left kasi tinoxidize. So let's say you use a zinc electrode and then zinc ion aqueous, each has a concentration of 0.1 molar kasi 1.0 times 10 raised to negative 1. So ala nang alagay salt bridge and then ano nangyari? So here we have VO2 positive here, which is a concentration of 2.0 molar, then comma, then each which has a concentration of 0.5 molar, and then comma ulit, continuation lang yan. Continuation lang, sorry. Teka. Here, nasan ba? Ayan. So, comma. Then for the VO2 positive, which has a concentration of, where's the, nasa yung mouse one? 1.0 times 10 raised to negative 2. 1.0 times 10 raised to negative 2 molar. Ayan. So, junction, let's say we use a platinum electrode for this. So, that's how you describe in terms of cell notation for this reaction. Ayan. So take a screenshot, guys, so we can proceed on our next problem. Ayan. Here. Medyo magulo nga lang. So, ayan. So, let's proceed to our next problem. Second to the last. Actually, last problem here. So, this now is a calculation of equilibrium constant. Ayan. Okay. Dito, let's say we want to calculate the equilibrium constant to this. And ito yung lumabas na reaction. Tama? Ngayon, ang mangyayari dito, okay, first and foremost, there are two methods that you can use. Pwede kang gumamit ng Nernst equation or the negative RT ln Q. Okay, tutukoyin ko dito. Okay. The method number one, there are two approaches to us to this solve. The formula of delta G is equals to negative N F E naught is equals to negative RT ln KEQ. Ayan. So further derivations. Ayan. And then sa method number 2 naman, you will use pwede agad ng E cell equals to E naught cell minus 0.05915 all over N log KEQ. Take note guys, ang sinasolve nyo dito is yung KEQ. Kapag ang kasi at equilibrium guys, at equilibrium, E cell is equals to 0. So magiging 0 yan. Which in turn, kapag nag-derive ka, mamaya na yan. Sige, mamaya na. Ayan, yan yung pwede natin. So, gamitin natin yung method 1. Method 1. Ilan ba yung natin dito? Ayan. So, here, ang dito is, ayan. Pwede muna natin. Ayan. Oxidation and reduction. So, computein mo natin E naught nito, yung E naught. So, E right, ano yung E right? Nasa anode, mas malaki, 1.7. Ano yung nasa anode, the reduction or the E left? That is 0.767 volts. Which, meron na tayong, dito will have a value of 0.933. 0.933 volts. Now, the 0.933 volts here, ayan, so E naught equals to 0.933 volts. So, gamitin natin yung method 1, which is negative NFE naught equals to negative RT ln KEQ. So, since this is both negative, so positive na yan, let's isolate for the KEQ. So, how do we do that? First, ayan, no? Ln KEQ equals to, ayan, bababa mo lang dito, NFE naught all over RT. Okay? Ano na ulit yung 1? Yung 1 natin dito, yung T, di ba? It is always 25 degrees Celsius. And how do we con dito? How does that isolate per ln? U is the exponent. So, na-isolate na natin na KEQ equals E raised to NFE not cell all over RT. Ayan. So, ayan, direct substitution na lang. Ilan ba yung moles electron na gamit? Only 1. Only 1 lang naman. So nandito is just a E raised to 1 times the Faraday's constant na 964,485. Yan, I will drop the unit na muna. So 0.933 for the E naught. Ayan. All over the gas constant, which is a 0.08145 joules per mole Kelvin. And ang temperature natin is 0.5 Kelvin. Ayan. So the answer to this is the KEQ will be ayan, 5.899 times 10 raised to 15. Saan yung sagot? Nag-confirm ba? Here. Actually, it's times 10 raised to 16. Pero ayan. Okay, let's try the method 2. Let's try the method 2 naman, which is ito naman tayo. Dito naman, using the E cell. Okay, so the method 2, try natin. So the E cell equals to E naught minus 0.05915 over N, tapos log K EQ. Ngayon, E cell is 0. Kasi E cell at equilibrium, cell is 0. So, mangyari, pag 0 yan, you will transpose this to the other side. You will generate a E naught of A cell is equals to 0.05915 all over 1, kasi nga di ba 1 electrons lang, and then log K. And then further isolation, okay, so log K is equals to the E naught cell all over 0.05915. And then, para matanggal yung log, you will use the exponential term here. Ayan. So, mangyayari, 10. Sorry. So, the K, EQ, or K will be 10 raised to the E, not cell, all over 0.05915. Okay. Now, let's substitute the known values. Then, the E cell is ano ulit? 0.933 all over 0.05915. Ayan. So, maging sagot natin dito, guys. Ang sagot naman dito is 5.935 times 10 raised to 15. Ayan. Na kung saan kung pag-compare nyo yung dalawa, is hindi sila nagkaalayo ng values. Ayan. So, may konting variation lang. But the values are close to one another. So, pwede nyo gamitin either of the two methods. And you'll get the exactly approximate same answer. Ayan. So, take screenshot, guys, so we can proceed to our next problem here. Here, one, dito. Then dito. And then, ayan, dito, and ayan. So, ito, tong part na to, this will be a part of your learning activity. And this is also will be part of your learning activity. Okay, so thank you guys for listening, and I hope you learned something in this lesson. So see you in the next module and for our learning activities. Thank you.